This is mathheals.com, where you can find links to more math YouTube videos. I'll learn to speak someday. Let's take a look at multiplicative inverses of matrices and matrix equations. Now, let's talk a little bit about inverses. We got our matrix A. The inverse is represented by what looks like this. Looks like A to the negative 1 power. That's not to the negative 1 power. That's to the inverse of A. And that's given by something. Well, if you multiply A times its inverse, you're going to get the identity matrix. We'll talk more about that here in a second. And if you take the inverse times A, you're also going to get the identity matrix. Well, what is the identity matrix? The identity matrix, if I looked at a 2 by 2, we would have diagonal ones, zeros everywhere else. If I looked at one that dealt with three rows, 3 columns, we'd have 1, 1, 1, diagonal ones, zeros everywhere else. That's the identity matrix. Not too important in terms of college algebra purposes. If you take other stats courses, take graduate stats courses, you'll see this a lot. So it does come into play a lot there. If you're playing a video game, a three-dimensional video game keeps track of the position of anything on your game with a 4x4 matrix. And if your character is right at the very beginning, hasn't moved at all, it's this one. So this is our identity matrix with a 4x4. Well, his first problem, say, find the products A and B and BA to determine whether B is a multiplicative inverse of A. So we're wanting to multiply those together. So we got 2, negative 3, 1, and 4. And for B, 7, negative 1, 5, and 9. Well, we first have to multiply A times B, and this should give us the identity matrix. And B times A should also. And if they do, then those are inverses of each other. Okay, so I'm going to take 2, negative 3, 1, 4, times 7, negative 1, 5, 9. Okay, multiply this row times this column. So we got 2 times 7 minus 3 times 5. 2 times 7, negative 3 times 5. Then this row times this column. So 2 times negative 1, negative 3 times 9. And we'll apply this row times this column. 1 times 7, and 4 times 5. Then we'll apply this row times this column. So we've got 1 times negative 1, and 4 times 9. Well, this is 14 minus 15. This is negative 2 minus 27. This is obviously not going to give me my identity matrix. Diagonal 1, zeros everywhere else. This is not 0. So I don't even need to go any further. Once you see that, then you can say A and B are not inverses. Not that I can spell. So A and B are not inverses. You don't have to check B times A. Because both of them have to give you the identity matrix. So if one fails, then they're not inverses. Well, let's do this on the calculator. So I'm going to go on my matrix menu, second, x and negative 1, right arrow over to edit, enter on A, 2 by 2, so 2 inner, 2 inner. And we got 2 inner, negative 3 inner, 1 inner, 4 inner. Exit out, second mode. Go back into our matrix menu. Right arrow over to edit, down arrow to B, inner, and it's 2 by 2. And we got 7 inner, negative 1 inner, 5 inner, 9 inner. Exit out, second mode. Now we're going to multiply the 2 together. So go into matrix menu, do inner under on A. Go back in my matrix menu, second x negative 1. Down arrow to B and press enter, and enter again. We see we're getting negative 1, negative 29. And again, it's not a diagonal of 1, 0, 0, everywhere else. So again, they're not inverses. Let's look at the next one. Got A is equal to 7, negative 4, negative 2, and 3. And B is equal to 3/13, 4/13, 2/13, and 7/13. And we'll multiply A times B. So 7, negative 4, negative 2, 3 times 3/13, 4/13, 2/13, and 7/13. Okay, take this first row times the first column. So I got 7 times 3/13 and negative 4 times 2/13. Then this row times this second column. So 7 times 4/13 minus 4 times 7/13. Then our second row here times our first column. So negative 2 times 3/13 plus 3 times 2/13. And then our second row times our second column. So we got negative 2 times 4/13 plus 3 times 7/13. Let me look for the patterns. 7, negative 4, 7, negative 4, negative 2, 3. Okay, that all looks okay. I'm about out of space. That's 21/13 minus 8/13. 21 minus 8 is 13/13, which is 1. That's 28/13 minus 28/13, which is 0. This is negative 6/13 plus 6/13, which is 0. And this is negative 8/13 plus 21/13, which gives us 13/13, which is 1. And that checks. Now we also have to multiply B times A. I guess I'll continue that on the next page. I should have started a new page after that first problem, but poor planning. Okay, so we got A is equal to 7, negative 4, negative 2, 3. And B is equal to 3/13, 4/13, 2/13, and 7/13. And we want to find BA. So we got 3/13, 4/13, 2/13, and 7/13 times 7, negative 4, negative 2, and 3. Okay, so take our first row times our first column. So we got 3/13 times 7 plus 4/13 times negative 2. Then take our first row times our second column. So we got 3/13 times -4 plus 4/13 times 3. Then our second row times our first column. So we got 2/13 times 7 plus 7/13 times -2. And our second row times our second column. So we got 2/13 times -4 plus 7/13 times 3. Now multiplication is not commutative, so that's why we couldn't be just happy with A times B giving us the identity matrix. Okay, let me double check my patterns, see if I look like I'm doing it right. Yeah, okay. 21/13 minus 8/13 is 13/13 or 1. -12/13 plus 12/13 is 0. 14/13 minus 14/13 is 0. And -8/13 plus 21/13 is 13/13 or 1. So that checks. So, since both of them give us identity matrix, then A and B are inverses. Multiplicative inverses. Well, let's check this on the calculator. Go to my matrix menu, go over to edit, enter on A. It's a 2 by 2, so 2 enter, 2 enter. And we got 7 enter, -4 enter, -2 enter, 3 enter. Exit out. Go back in my matrix menu, second exit -1. Go over to edit, down arrow to B, enter. And it's a 2 by 2, so 2 enter, 2 enter. And fractions, you just put them in just like normal. So 3/13, you do 3 divided by 13. Enter. 4/13, 4 divided by 13. 2/13, 2 divided by 13. And then 7/13, so 7 divided by 13. Then you want to exit out. Okay. Now to multiply these two together, go in our matrix menu, enter on A, go back into our matrix menu, down arrow to B, press enter, and enter again. And we got our diagonal 1, 0, 0 else. Well, let's find B times A. So go back in our matrix menu, I'm going to down arrow to B, enter. Go back in my matrix menu, enter on A, enter again. And we got our diagonal 1, 0, 0 else. So that right there shows their inverses. I'll grab a drink here and then we'll look at the next problem. Now this one gets into how to find the inverse. And there's a shortcut for a 2 by 2. Okay, so we got A is equal to 3, -2, 4, 1. And it says, for a shortcut, if A is equal to A, B, C, D, then our inverse is going to equal to 1 over AD minus BC, and D, -B, -C over, or an A, sorry, not over. Okay, D, -B, -C. Okay, I got everything written down correctly. Well, this would be our little a, this would be our little b, this would be our little c, and this would be our little d. So, to find our inverse, we just plug in the a, b, and c we just identified into our formula. So we got 1 over a times b, so 3 times -2, minus, is that really b times c? Yeah, it is. A times d. Ah. Okay, that didn't seem right when I was doing it. It's like, I've worked this method, it's AD. AD minus BC. I even double checked myself. Okay, so I take A, which is 3, times D, which is 1, minus B, which is -2, times C, which is 4. And then Here we put D, which is 1. B, which is a negative 2. C, or negative C, which is a negative 4. And A, which is 3. Now let me double check myself. AD, so AD minus BC. This is D. 3, negative, okay. Which then gives us 3 times 1 is 3. Minus becomes a plus. 2 times 4 is 8. This is 1, 2, negative 4, 3. Which gives us 1/11 times 1, 2, negative 4, and 3. Which would give us 1/11 times 1 is 1/11. 1/11 times 2 is 2/11. 1/11 times 4, negative 4 is negative 4/11. And 1/11 times 3 is 3/11. And that'd be your answer. Let's take a look at this on the calculator to find the inverse. Even if you do it by hand, being able to do it on a calculator is very nice to check your answer. So let's put in our matrix first. So do second, x to negative 1, right arrow over to edit, enter on A, 2 by 2, so 2 inner, 2 inner. And our matrix is 3 inner, negative 2 inner, 4 inner, 1 inner. And we want to exit out, so do a second mode. Okay, now to get our inverse, to find what looks like A to the negative 1, that's the inverse of A, we're going to go into our matrix menu, do second, x to negative 1, enter on A, and this button I've been referring to over and over as x to negative 1, that's our inverse button, so you press it. People just click better if I say x to negative 1. And then you see how it puts a negative 1 there, and then we'll press enter. Now some calculators, not very many, but some will let you do a caret negative 1. But most of them won't. Now we get decimals. We know how to handle that. We press math, enter. And we get 1/11, 2/11, negative 4/11, and 3/11. Same answers we got here. And that's how you do it on the calculator. Let's take a look at the next problem. Says find our inverse by forming this weird looking symbol. We'll talk more about what this means. And then use row operations, blah blah blah. Okay. Sometimes instructions don't make any sense until we actually work the problem the first time. And then it's like, oh okay, that's what they mean by that. 3, negative 1, 4, 5. What they're saying here, to find the inverse, that we're going to take A. We'll write A down here. And I'll put a line going across there. And over here, we're going to put the identity matrix. Since this is a 2 by 2, we'll put a 2 by 2 identity matrix. Diagonal of 1, zeros everywhere else. Now our goal, that's this right here. That's what that notation means. Now our goal is to get the identity matrix. See how it's on the right side here? We want to get it on the left side. And we want to use row operations to do this. Well, first thing we want to do is we want to get a 1 here. So I'm going to divide everything in row 1 by 3. So we'll take row 1, divide by 3, and that gives us our new row 1. 3 divided by 3 is 1. Negative 1 divided by 3 is negative 1/3. 1 divided by 3 is 1/3. 0 divided by 3 is 0. Okay, we want to get a 0 below it. So you ask yourself, what do you multiply times a 1 that then added to the 4 will give you a 0 here? Well, if I multiply this by negative 4, negative 4 times 1 is negative 4 plus 4 is 0. So we're going to take negative 4 times row 1 and add it to row 2 to get us our new row 2. Negative 4 times 1 is negative 4 plus 4 is 0. Negative 4 times negative 1/3 is 4/3 plus 5 gives us 19/3. Negative 4 thirds plus 5, 15, 19 thirds. Okay. Then we'll take negative 4 times 1 third. That gives us negative 4 thirds plus 0. So that's negative 4 thirds. Negative 4 times 0 is 0, plus 1 is 1. Okay. Now we want to get a 1 here. And I could do it all in once, but I'm gonna first multiply everything in this row by 3. That'll get us a step closer. So I got 1, negative 1 third, 1 third, and 0. And we're going to take 3 times row 2, and that's going to give us our new row 2. 3 times 0 is 0. 3 times 19 thirds is 19. 3 times negative 4 thirds is negative 4. 3 times 1 is 3. Okay. We still want to get a 1 here. Well, now I can divide everything in that row by 19. So 1, negative 1 third, 1 third, 0. And I'll take row 2, divided by 19. Gives us our new row 2. 0 divided by 19 is 0. 19 divided by 19 is 1. Negative 4 divided by 19 is negative 4 19ths. 3 divided by 19 is 3 19ths. Last thing. I need to get a 0 here. Okay. Now I look at the 1 here, ask myself what to multiply times the 1 that I then can add to this negative 1 third to give me a 0 here. Well, that was 1 third. We'll take 1 third times row 2 and add that to row 1 to get us our new row 1. 1 third times 0 is 0, plus 1 is 1. 1 third times 1 is 1 third, plus negative 1 third is 0. 1 third times negative 4 19ths. 1 third times negative 4 19ths plus 1 third. Now, that gives us negative 4 over 3 times 19. And here, multiply top and bottom by 19, I get 19. So that gives us 15 over 7 to 57, which reduces 5 and 5 19ths. Negative 4, okay, times 19, 15, looks right. Okay, now 1 third times 3 19ths, 1 third times 3 19ths, and then add the 0. 3's cancel us, that's 1 19th. Okay. We had the identity matrix on the right side. We now have it on the left side. That's what we're shooting for. We wanted to get it over here, which we did. This on this side is now going to be our inverse. So we're wanting to find the inverse. Assuming I didn't make a math error, which is very likely. This is 5 19ths, 1 19th, negative 4 19ths, and 3 19ths. Well, let's use a calculator to check our work here. So I'm going to put this in my calculator. Press my math. What am I doing math? Never mind, I'm lying. I'm watching a zombie movie when I should be working here. I'm going to go in a second to x negative 1. And right arrow over to edit. Enter on A, 2 by 2. And we've got 3... enter, negative 1, enter, 4, enter, 5, enter. Exit out. Now to do our inverse, we'll go into our matrix menu, second x and negative 1, enter on A, and then we'll press our x and negative 1 key. This is the inverse. And then press enter. We get decimals, so we do math, enter, enter. And 5 19ths, 1 19th, negative 4 19ths, and 3 19ths. And that's our answer. Now you're maybe sitting there thinking, well, you know, this is kind of hard, those steps through there. It's even worse with a 3 by 3. I'm showing you an easy one. But you get 3 by 3, 4 by 4, 5 by 5, it becomes hideous. Why show this method? We got that shortcut that we looked at in the previous problem. Shortcut only applies when you got a 2 by 2. Doesn't apply when you got a 3 by 3, 4 by 4. So if you're doing it by hand, you have to know this technique right here. Now we're going to use this the inverse to help us solve some equations. And that's what this next one's talking about, is solving equations. So let's talk a little bit about it. Okay, so I got AX is equal to B. These are matrices. Well, I can solve for X by multiplying both sides by the inverse. Oftentimes this is written lowercase. Now when you take an inverse times the inverse of A times A, they cancel each other out. So we'd have this right here. Our answers are equal to the inverse of A times B. I'm going to put that up here because we're going to use that in some of these next problems. And actually they use capital. I have capital B here. Probably not by choice. Probably the PowerPoint made it capital for me, assuming they knew what was best. Okay. So here we got 3x plus 7y equals 10. We got 4x minus 2y is equal to 9. Well, first off, let's identify our different matrices. Now A is the numbers off of our variables. So over here on the left side we'd have 3, 7, 4, negative 2. Some books refer to that as a coefficient matrix. And our capital X, that's our variables. So that'd be X, Y. And then B will be our numbers on the right side, which will be 10, 9. So again, that's how you identify those three. Now to find our answers, we have to have B, which we got, and we have to find the inverse of A. So let's do that first. Okay, so I got 3, 7, 4, negative 2, and I'm going to use this technique. Because again, it best prepares you if you're dealing with the 3 by 3. Let me grab a drink. Excuse me. Okay. We'll want a 1 here. So we're going to divide everything in that row by 3. So 3 divided by 3 is 1. 7 divided by 3 is 7/3. 1 divided by 3 is 1/3. 0 divided by 3 is 0. So I took what row 1 divided by 3 gives me my new row 1. 4, negative 2, 0, 1. We want to get a 0 right below it. So I'm going to multiply the first row by negative 4. So negative 4 times row 1, and add that to row 2 to get our new row 2. Negative 4 times 1 is negative 4 plus 4 is 0. Negative 4 times 7/3 is negative 28 over 3 minus 2. That gives us negative 34 over 3. Let me double check that. Negative 28 over 3 minus 2. That's negative 6, negative 34 over 3. Yep. And then negative 4 times 1/3 is negative 4/3 plus 0. So that gives us negative 4/3. Negative 4 times 0 is 0 plus 1 is 1. Now, we want to get a 1 here. I can start off by multiplying everything by 3 to make my life a little easier. So I got 1, 7/3, 1/3, 0. multiply everything by 3. So I'll take 3 times row 2 gives me my new row 2. 3 times 0 is 0. 3 times negative 34 over 3 is negative 34. 3 times negative 4/3 is negative 4. 3 times 1 is 3. Well, we still want to get a 1 here, so we'll divide everything by negative 34. So 1 7/3, 1/3, 0. And I'll take row 2 divided by negative 34. And that's going to give us our new row 2. 0 divided by anything is 0. Negative 34 divided by negative 34 is 1. Negative 4 divided by negative 34 is 4/34 or 2/27. 4/34, 2/27. Okay. And 3 divided by negative 34 is negative 3 over 34. Okay, now last thing is I need to get a 0 here. Okay, I'm going to multiply the second row by negative 7/3, so negative 7/3 times row 2 and add that to row 1 to give me my new row 1. Negative 7/3 times 0 is 0, plus 1 is 1. Negative 7/3 times 1 is negative 7/3, plus 7/3 is 0. Negative 7/3 times 2/27 plus 1/3. That gives us negative 14 over 3 times 27 plus, multiply top and bottom by 27. So that gives us 13 over something. 81. Boy, that seems bizarre, doesn't it? I'll double check this in a minute. Take negative 7/3 times negative 3/34. And then I'll add 0. So 3's cancel, that becomes 7/34. Maybe. How can I check it? Well, if I take my original A, and this is checking it by hand, of course. Original A was 374, negative 2. 374, negative 2. 374, negative 2. If I multiply that times this, so we're saying that's our inverse now. 13 over 81, 7 over 34, 2 over 27, negative 3 over 34. Okay, multiply these together. 3, that's 39 81s, and this is 14 27s. That gives 42, 72, 81. Okay, that does give us 1. Okay, now I'll take this times this, so that gives me 21/34 and minus 21/34, which is 0. This one is 52 81st minus 4/27, multiply top and bottom by 3. That's 12. Wait a minute. 52 over 81. That's negative 4 over 27. Okay, I screwed up. Let's go back and check. Divide everything by 3. Well, first, let me make sure I wrote it down correctly. 374, negative 2. Divide everything by 3. So I get 7/3, 1/3, 0. Okay, that looks good. Okay, need a 1 here, so multiply everything by negative 4. Negative 4 times 1 plus that is 0. That's negative 28/3 and negative 2. Negative 28/3 and negative 2 gives us negative 6, negative 34/3. That's correct. And negative 4 times this is negative 4/3 plus 0 is negative 4/3. Gives me 1. That looks correct. Multiply everything by 3. Looks good. Divide everything by negative 34. Negative 4 divided by negative 34. The negatives cancel. We've got 2/17. Pah! And this one, let's see what that gives us. Okay. 3, that looks correct. So down to here. Glad I checked that. 2/17. And down to here. 17ths. Okay. And so then I did this times this. It's curious I came up with the 1 there, unless I just did my math wrong. There we go. So this gives us 3 times 13 is 39/81s. 7 times 14. 17s. Okay, so multiply that by, what do I multiply that by? 4, 5, 3, 17, 3. Well, let me get my calculator. I still got something wrong up here. Let me go up here and check again. Darn it. Okay. I feel good down to that step. Maybe. Okay, negative 7. Oh, I didn't change this, did I? Since I changed this one, then this one's going to change completely. I hate matrices. Okay, negative 7/3 times that. So we got negative 7/3 times 2/17. And then I'll add what's already there, which is a 1/3. Which gives us negative 14, 3 times 17, plus 17 over 3 times 17, which gives us 3. 3/51s, which gives us 1/17. You're gonna see this is so much easier using the calculator to do a lot of it, but okay. You'd be sitting there, why are you doing this by hand? And good question. Okay, so this is 1/17. So that's 3/17 plus 14/17, 17/17, 1. Okay, that works. This is 21/34. That's minus 21/34. That's 0. That works. 4/17 minus 4/17 is 0. That works. 28/34. 28/34 plus 6/34 is 34 over 34, which is 1. So now I'm going to run an assumption. I checked it just one way, going from this a times or what we think is the inverse to check it. In theory, we'd check the other way, but I'm pretty comfortable now. If you get it one way, it's probably a pretty safe bet it's going to work the other way too. Because that'll have gotten rid of any math errors you had in there, like I just had. Now, it's a good thing to realize is that you have to check this stuff because if you're doing it by hand, it's sometimes hard to get that correct answer. It's so easy to add numbers wrong, multiply, subtract, so forth. Okay, so our inverse, assuming I wrote it down correctly, is 1/17, 7/34, 2/17, and negative 3/34. And we want to multiply that times b. Well, b was 10/9. Okay, so let's multiply that together. So I take 1/17. We're taking this row times this column. So 1/17 times 10. And 7/34 times 9. Then this row times this column. So we've got 2/17 times 10 minus 3/34 times 9. Okay. That gives us 10/17 plus 63/34. This gives us 20/17 minus 27/34. And we need to get a common denominator, which would be 34. So multiply that times 2. Multiply this by 2. So we get 20 plus that. So 83/34. And multiply this by 2. This by 2. We got 40 minus 17 is 13/34. Well, that seems kind of bizarre. So let me double check myself. So my inverse down here was 1/17, 7/34, 2/17, negative 3/34. 1/17, 7/34, 2/17, negative 3/34. B was 10 and 9. So that's 10/17 plus 63/34. That's correct. This is 20/17 minus 27/34. That's correct. Times 2. That's 40 minus 13. Or okay, 40 minus 27, 13. This is 20/83/34. And I'm assuming 17 doesn't go in 83. Nope. So let's actually check these now. Because this would be x and this would be y. So we're saying our answer is 83/34 and 13/34. Okay, so we're going to check that into our original equation and see if that works. That's a true test. So we're going to check it in 3x plus 7y equals 10. We'll also check it into 4x minus 2y equals 9. Okay. So now we're going to plug in 3 times x, which is 83/34, plus 7 times 13/34. Now we're wondering if that's going to give us 10. And that's 9, that's 249/34. Plus 1291/34, which gives us 0, 1, 10, 14, 1, 340 divided by 34, which gives us 10 equals 10. Checks. Now if I put that in for over here, I got 4 times 83/34 minus 2 times 13/34. I'm wondering if that equals 9. It gives us 332/34 minus 26/34. 306/34. 9 times that, 327 plus... let me do my calculator. 306 divided by 9. Okay. So I was trying to do it all by hand, as much as I could. So that checks. Okay, so this is our answer. Well, that's how to do it by hand. Now in the calculator, we learned before a method called RREF. And let's take a look at that. Now with RREF, we need our augmented matrix. So we got 3, 7, 10, 4, -2, and 9. Let's first do it with RREF and see what we get. Well, we want to go put that in our matrix. So we'll do second, x to -1, go over to edit, enter on A, rows by column, so this is 2 by 3, and we got 3 inner, 7 inner, 10 inner, 4 inner, -2 inner, and 9 inner. Exit out, so that's inputting our matrix in. Then we'll go back into our matrix menu, second x to -1, right arrow to math, up arrow to RREF, one with 2 R's, press enter, go back into our matrix menu, do enter on A, and enter again. Now we got decimals, we know how to handle that, we press math, enter. Now we had 2 equations, 2 variables, so our first 2 by 2 matrix should be a diagonal 1s and 0s everywhere else, and it is. And we came up with 83/34 and 13/34, which is what we got right here. Okay, that's a RREF method. Well, let's actually use this formula here using our calculator. So I'm going to put this into A, and I'll put this into B, and let's see how to do it. So I go to my matrix menu, right arrow over to edit, do enter on A, 2 by 2. And we got 3 inner, 7 inner, 4 inner, -2 inner. Exit out, go back into my matrix menu, go over to edit, down arrow to B, and this one is rows by column, so 2 by 1, so 2 inner, 1 inner, and we got 10 and 9, so 10 inner, 9 inner, then exit out. Okay, we got all our matrices entered. Well, we're going to type this in exactly as you see it. So we got the inverse of A, so go into the matrix menu, second x to -1, enter on A, press our inverse button, go back into our matrix menu, down arrow to B, and that's the inverse of A times B, and press enter. Now we get decimals, so you do math, enter, and we get our 2 answers. Well, if our REF does it so much simpler than even using a calculator with the way we just did here, why would you want to learn this? There are some calculators that do not have the RREF method on it, but they do have an inverse capability on them. So if you got a calculator that has the inverse but not the RREF, you can use this to find your answers. Anyway, very hideous by hand, as you saw. Actually, it didn't say for us to actually solve that one. Oh well, I'll give you extra practice. Now this one says write each matrix equation as a system of linear equations without matrices. So we got 2, -3, 4, 5. And then here we got x and y. I guess I should read directions. It's a failing of mine. I don't follow directions very well. Okay, write each matrix equation as a system of linear equations without matrices. This is like going backwards. You take this row times this column, so 2 times x, and -3 times y, -3y, equals -1. Then take this row times this column, 4 times x, 5 times y, equals -7. And those are our answers. Okay, this one wants us to actually solve it. But they cheat. They give us the inverse. But I showed you one complete problem by hand. which is probably good because this kind of leads you into thinking they're easy, and they're not, as you saw. Now I wouldn't even try to do a 3 by 3 completely through. 2 by 2 is hard enough in terms of finding the inverse and going through all that. But anyway, write each linear system as a matrix equation. So let's start off first with that. We got 3x minus 5y plus z equals -1. Then x minus 3y minus 2z is equal to 3. I was actually wondering on that one why I made it so hideous. It's because I didn't say to actually solve it. Usually when I'm showing one, I try to make them come up nice, like, you know, with x equals 1, and y is equal to 2 or something like that. Okay. Now our A is going to be our coefficient matrix, the numbers off of our variables. So we've got 3, -5, 1, 1, -3, -2, 4, 1, and 3. Let me double check my signs. Looks good. Now our B is going to be our numbers on the right side. -1, 3, 3. And to solve it, we would need to plug it into this formula here. Well, this one helps us. It says solve the system. Actually, I didn't completely set that up. What they're implying, I'm not sure why, but they want you to write it this way. Still not following directions. There's a mystery in the form that. Okay, so then we'd have x, y, and z here, and then -1, 3, and 3. This would be your A, this would be your x, and then this would be your B. But this will give us our answer. Well, we need our inverse of A, and I'm not going to go through and do this by hand. I've cheated, and I've written it down here. The inverse of this is this. So we got -7 over 47, 16 over 47, 13 over 47, -11 over 47, 5 over 47, 7 over 47, 13 over 47, -23 over 47, and -4 over 47. Times B, which would be -1, 3, and 3. And that'll give us our answers. So let's see how I do. So I'm going to take this row times this column. So -7 over 47 times -1 gives us +7 over 47. 16 over 47 times 3 gives us 48 over 47. 13 over 47 times 3 is 39 over 47. Then this row times this column. Second row times this column. -11 47ths times -1 is +11 47ths. 5 47 times 3 is 15 47ths. 7 47 times 3 is 21 47ths. Then our third row times this column. That gives us -13 47ths minus 69 47ths minus 12 47ths. Assuming I didn't make a basic math error. Okay. 48 plus 39, that's 79, 87, 94. So 94 over 47ths, which is 2, I guess. This is 11 plus 15 is 26, 46, 47 over 47, which is 1. And this one is 69 and 12 is 79, 81, -81, -84, -94 over 47. Which, like I said, is 2, 1, negative 2. So that's x, that's y, and that's z. So our answer would be 2, 1, negative 2. Okay. If I was going to do this on the calculator, again, not everybody has the RREF method. I put in A and B in my calculator. So go into my matrix menu, right arrow over to edit, enter on A. It's a 3 by 3, so we do 3 enter, 3 enter. Let me grab a drink here. Okay, then we got 3, enter, negative 5, enter, 1, enter, 1, enter, negative 3, enter, negative 2, enter, 4, enter, 1, enter, 3, enter. Okay, now exit out, so do a second mode. Go back in my matrix menu, go over to edit, down arrow to B, press enter. Rows by columns, so, oops, 3 by 1. Negative 1, enter, 3, enter, 3, enter. Now I want to exit out. Okay. Now we're ready to put this in. Inverse of A times B. So I'll go to my matrix menu, enter on A, press my inverse button, go back to my matrix menu, down arrow to B, and press enter. And we get 2, 1, negative 2, which is what we came up with by hand. Or somewhat by hand. I was too lazy to actually find the inverse of this by hand. You can see from the great success I had in the previous problem that there's a reason why I didn't do that. You know, here I was just finding the inverse of 2 equations, 2 variables, so 2 by 2. Not that easy. Calculator will make your life so nice on these, unless you got an instructor that wants you to do them by hand. So I would encourage you. I usually I have students at some point they'll go out and buy a TA3, TA4 for my class, and it's usually at this point where they're doing these by hand and they're just hideous. And so well, maybe it's worth it to go buy the calculator. Let me go ahead and stop the recording here. Oops. Did I save that? Okay.